What if you are not the only version of you reading this right now? Parallel universes are not just science fiction. They are serious scientific theories that could completely rewrite our understanding of reality. By the end of this journey, you will discover 25 shocking theories about the multiverse that challenge everything you think you know. We will explore how every choice you make might create a new reality, and whether our entire universe is just one page in an infinite cosmic book. What is the one thing you thought was absolutely impossible that might actually be real? The very fabric of reality might be splitting apart with every breath you take. This is the startling promise of the many worlds interpretation, a theory proposed by physicist Hugh Everett. It begins in the bizarre realm of quantum mechanics, where particles can exist in multiple states at once, a phenomenon known as superposition. The classic thought experiment to illustrate this is Schrödinger's cat. A cat is placed in a sealed box with a device that has a 50-50 chance of releasing poison. Until you open the box, quantum rules state the cat is both alive and dead, a ghostly mixture of both states, but the many worlds theory offers a radical solution. The moment you lift the lid, the universe does not choose one outcome. Instead, it splits in two. In one universe, you find a living cat relieved. In another, completely separate reality, a different version of you looks into the box and finds a dead cat. Both events are equally real, happening in parallel worlds that will never interact. Now, extend this idea beyond a single cat in a box. Apply it to every tiny quantum event, every particle collision, and every choice you have ever made. The moment you decided to watch this video, another you in a branching reality decided to do something else entirely. Every path not taken, every word left unsaid, every chance encounter that defined your life has spawned a new universe where a different story unfolds. This means there are realities where you are a famous musician, an astronaut, or live in a world with a different history. Every possible outcome of every event exists somewhere in the vast multiverse. Probability, as we understand it, ceases to exist. There is no chance, only certainty that everything that can happen does happen in its own separate cosmic stream. The implications are staggering, suggesting an infinity of yous, living out every conceivable version of your life across an endless sea of existence. But if every choice creates a new world, what are these worlds actually made of? The mathematical universe hypothesis offers a startling answer. They are not made of matter or energy, but of pure mathematics. Proposed by physicist Max Tegmark, this theory suggests that our physical reality is not just described by math, it is math. Every equation is a potential universe, and every possible mathematical structure exists as a real, physical reality somewhere in the multiverse. Our cosmos, with its 3 dimensions of space and 1 of time, is just one specific mathematical structure that has somehow become conscious. It is the set of self-consistent rules that allow for stars, planets, and us. But an infinite number of other mathematical systems exist, each one a separate universe with its own bizarre laws. Imagine a universe built on the simple geometry of a 4-dimensional cube. In that reality, a being could move in a direction you cannot even conceive. Or consider a cosmos where the number 2 does not exist and the very concept of pairs is impossible. There could be a reality where gravity repels instead of attracts, where time runs in loops instead of a straight line, or where the speed of light is not a constant but a variable that changes with the color of the sky. These are not just imaginative fantasies under this hypothesis. They are as real as our own universe, simply because their underlying mathematics is consistent and possible. The most profound consequence is that you, the observer, are also part of this mathematical structure. Your thoughts, your consciousness, and the very feeling of being alive are emergent properties of a complex computation running on the hardware of spacetime. We are a piece of the universe that has become aware of itself, a pattern within the math that has started to look back and wonder about its own existence. This leads to a truly humbling thought. Every beautiful symphony, every heartbreak, every moment of human history is, in its essence, a mathematical pattern playing itself out. And somewhere, in the infinite library of all possible equations, another pattern is unfolding in a reality so alien we could never even dream of it. Our own universe might be just one fragile bubble in an endless cosmic foam. This is the essence of the bubble universe theory, a concept born from our most advanced models of the Big Bang. According to cosmic inflation theory, the very beginning of everything was a period of unimaginably rapid expansion. But this inflation did not happen evenly everywhere at once. Think of it like a pot of water coming to a boil. Bubbles form, expand, and drift apart in the steaming water. In the same way, different patches of the primordial cosmos inflated at different rates, each one pinching off to become its own self-contained universe, a separate bubble in a vast multiversal sea. Each of these bubble universes could be born with a unique set of physical laws. The fundamental constants that govern our reality, like the strength of gravity or the power of the nuclear forces, might be randomly set when a bubble forms. In our bubble, these forces are perfectly tuned for stars to shine, for planets to form, and for life to emerge. But in another bubble, the nuclear forces might be too weak to ever bind atoms together into complex elements. That universe would be a dark, sterile expanse of hydrogen and helium, with no stars or planets at all. Another bubble might have gravity so intense that it collapses back into a singularity moments after it forms. We exist in a bubble where the numbers just happen to be right, a cosmic lottery winner in a sea of mostly uninhabitable realities. These bubbles are not completely isolated. They can drift and sometimes even collide with one another. If a neighboring universe bumped into ours, the collision would release an astronomical amount of energy. Scientists are actively searching for the evidence of such an event in the oldest light we can see, the cosmic microwave background. A strange, unexplained cold spot or a peculiar pattern in this relic radiation could be the cosmic bruise left by a collision with another bubble universe billions of years ago. Finding that imprint would be our first direct proof that we are not alone in the greater multiverse. This theory transforms our home from a singular cosmos into a single apartment in an infinite skyscraper of realities. We are not the center of existence, but merely one comfortable room in a building filled with endless, alien, and often hostile environments. It begs a haunting question. If our bubble is so fine-tuned for life, could its properties have been selected for a reason? Our three-dimensional reality might be nothing more than an incredibly complex illusion. This is the core of the holographic principle, a theory that reimagines the very nature of existence. The idea emerges from the study of black holes and a fundamental puzzle about information. When an object falls into a black hole, it seems to vanish along with all the information that described it. This violates a core law of physics which states that information can never be truly destroyed. To solve this paradox, physicists discovered that all the information describing the object swallowed by a black hole is not lost inside. Instead, it is perfectly encoded and preserved on the black hole's two-dimensional boundary, its event horizon. The three-dimensional reality we associate with the objects is, in essence, a projection from this flat, two-dimensional surface. Our universe in its entirety could operate on the same principle. The stars, planets, and even you are not fundamentally three-dimensional. You are a hologram. Every detail of our rich, volumetric world is actually encoded on a distant, two-dimensional surface at the cosmic edge, a surface we can never see or touch. Think of a credit card hologram where a flat, shiny sticker creates the stunning illusion of a three-dimensional image floating in space. Our universe could be the ultimate version of that sticker, a cosmic projection of unimaginable complexity. If our universe is one such hologram, then the multiverse could be a collection of other projections. Each parallel reality would be a different hologram, encoded on its own unique two-dimensional surface with its own set of rules. One universe might project from a surface where the code allows for 5 fundamental forces instead of our 4. Another might be built from information that permits time travel as a basic feature. The laws of physics in each reality would simply be the emergent properties of its specific informational code. This leads to a profound question about our own experience. If we are living in a projected reality, does that mean our thoughts and choices are also just part of the code? Is free will an illusion, a predetermined outcome of information processing on a cosmic scale? Or is consciousness itself the one thing that transcends the projection, the mysterious element that experiences the illusion? We are left to wonder if we are the programmers, the program, or something in between, living in a reality that is both breathtakingly real and fundamentally a phantom. Another universe could be hovering just a fraction of a millimeter away from your outstretched hand, separated not by vast cosmic distances but by a dimension you are physically unable to move through. This is the startling vision of the brane multiverse, a concept that emerges from the depths of string theory. In this framework, the fundamental building blocks of reality are not particles but unimaginably tiny, vibrating strings. For the mathematics of string theory to work, these strings must vibrate in a space with more than the 3 spatial dimensions we experience. There could be 6 or 7 extra dimensions, all curled up into a size so infinitesimally small that we are completely unaware of them. Our entire universe, with all its galaxies and stars, might be confined to a 3-dimensional membrane, or a 3-brane for short, floating within this higher dimensional expanse which physicists call the bulk. Think of our reality as a single, impossibly thin slice of bread. One slice in a cosmic loaf where every other slice is another, entirely separate universe. These parallel brane worlds could be floating right alongside our own, each with its own unique set of particles and physical laws. Some might be barren and empty, while others could be teeming with forms of life we cannot even conceive. The most dramatic interaction between these branes is a collision. When 2 of these massive membranes slam into each other in the bulk, the energy released could be cataclysmic. This collision might not be an end but a beginning. Some scientists propose that our own Big Bang was the result of such a brane collision, a violent event that set our entire cosmic history in motion. This leads to a cyclical view of creation where universes are born, expand, and eventually collide again in an endless cosmic dance. This theory also offers an elegant solution to a long-standing mystery in physics: why gravity is so astonishingly weak compared to the other fundamental forces. A magnet the size of a coin can lift a paperclip, effortlessly fighting the gravitational pull of the entire planet Earth. In the brane model, the explanation is that gravity is not confined to our brain. While all other forces and matter are stuck to our 3-dimensional sheet, gravity, which is the warping of spacetime itself, can leak out into the extra dimensions of the bulk. The gravity we feel in our universe is just a tiny fraction of its full strength, like the faint echo of a sound coming from another room. If we could perceive these extra dimensions, we might feel the full, overwhelming force of gravity, or sense the shadowy presence of another world hovering just beyond our fingertips. This idea transforms the void of space into a potentially crowded neighborhood, a stack of realities existing in perfect, imperceptible parallel. This thought experiment takes the many worlds interpretation to its most personal and unsettling conclusion. It is called quantum suicide, and it suggests a bizarre form of immortality. Imagine a person sits in front of a device that is linked to a random quantum event, like the decay of a single atom. Each time they pull the trigger, the device has a 50-50 chance of either firing a lethal bullet or simply making an audible click. According to classical probability, the person will almost certainly die after a few dozen attempts. But the many worlds theory paints a different picture. Every time the trigger is pulled, the universe splits. In one branch, the person dies, but in another, the gun clicks and they survive. Now, from the perspective of the person in the experiment, what do they experience? They only experience the timelines in which they are conscious. They pull the trigger once and hear a click. They pull it 100 times, 1,000 times, and they always, impossibly, hear a click. From their subjective point of view, they have become immortal. No matter how low the odds of survival are in a single universe, there will always be at least one branching reality where a miraculous sequence of quantum events prevents their death. They are forever trapped in the timeline where they live. This is not a suggestion to test this idea, as that would be incredibly dangerous and is only a theoretical exercise. The power of this thought experiment is purely philosophical. It forces us to ask what consciousness really is. Does our awareness somehow selectively follow the path where we continue to exist? Or is it that every version of us experiences their own continuous reality, and we are simply the one who has, so far, only experienced survival? The implications extend beyond a single room with a quantum gun. Every near miss in your life, every time you almost had an accident but did not, could be explained by this theory. In countless other realities, versions of you were not so lucky. But from your perspective, here and now, you have always been the one who made it through. This leads to a dizzying possibility. You might be fated to survive every potential catastrophe, not through divine intervention, but through the simple, cold math of infinite branching worlds. You are forever at the center of your own unlikely streak of good fortune, living a life that seems charmed, while an infinity of your other selves have already reached their end. Your own existence might be the most compelling evidence for a reality you cannot see. The simulation hypothesis proposes that our universe, with all its galaxies and human history, is not base reality. Instead, it is an incredibly sophisticated simulation, a kind of cosmic video game running on a computer of unimaginable power in a civilization far more advanced than our own. In this view, parallel universes are not cosmic bubbles or branching timelines, but something far more familiar. They could be different simulation parameters, like changing the rules of a game, or saved states from an experiment run over and over with slight variations. Philosopher Nick Bostrom formalized this idea with a stark argument. He suggests that at least one of three propositions must be true. 1. Almost all civilizations like ours go extinct before reaching a post-human stage. 2. Any advanced civilization has zero interest in running simulations of its own past. Or 3. We are almost certainly living in a simulation. If even a single advanced civilization ever chooses to run ancestor simulations, the number of simulated minds would vastly outnumber the real ones. Statistically, you are more likely to be one of the simulated beings. The clues might be written into the very code of our reality. Look at the Planck scale, the absolute smallest measurement of space. Reality appears smooth and continuous to our eyes, but at this fundamental level, it might be pixelated. Just like a digital image breaks down into tiny squares when you zoom in too far, space-time itself could be composed of discrete, indivisible units. This is exactly what you would expect from a simulation running on finite computing resources. Furthermore, the universe operates on a set of elegant mathematical laws. Gravity follows a perfect inverse square relationship. Light speed is a constant, and quantum mechanics is built on probabilities. These are not messy, organic rules. They are clean, consistent, and programmable, like the underlying physics engine in a video game. If our creators are running one simulation, why would they stop there? A civilization with such godlike technology would likely run countless simulations simultaneously, each with different starting conditions. One simulation might have a stronger nuclear force, leading to a universe where stars burn out in millions of years instead of billions. Another might have 5 spatial dimensions, creating geometries and life forms beyond our comprehension. Our universe, with its specific laws fine-tuned for life, could simply be one of many experiments, one particular run in an endless series of tests. This leads to a profound and unsettling question about our own consciousness. If we are living in a simulation, are our thoughts and feelings our own, or are they just incredibly complex algorithms processing simulated sensory data? Is free will an illusion, a predetermined outcome of the code? Or is consciousness itself the one thing that cannot be simulated, the spark of something real trapped inside a digital dream? We are left to wonder if the scientists searching for the laws of physics are merely reverse engineering the programming of our cosmic creators. Our existence might not be a single explosion from nothing, but the latest beat in an endless cosmic heartbeat. This is the theory of the cyclic universe, a model where the cosmos undergoes an infinite series of big bangs and big crunches. Instead of a one-time creation event, our universe expands from a hot, dense state, eventually slows its growth, and then collapses back upon itself in a great big crunch, only to rebound in a new big bang over and over for eternity. Each cycle is not a perfect copy of the last. During the violent collapse and rebirth, tiny quantum fluctuations, the same kind that seeded all the galaxies in our universe, could randomly tweak the fundamental constants of nature. In one cycle, the force of gravity might be a fraction stronger. In the next, the mass of an electron could be slightly different. These tiny changes mean that every new cycle is, in effect, a new universe with its own unique physical laws. The parallel realities in this model are not spread out across space, but strung along the arrow of time, each one a successor to the last. A profound question then arises. Does anything carry over from one cycle to the next? Some physicists speculate that while stars and galaxies are utterly obliterated in the Big Crunch, some fundamental information might survive the transition. The pattern of spacetime itself, like a cosmic fingerprint, could be imprinted onto the newborn universe. If this is true, then the history of a previous cosmos might be faintly encoded into the fabric of our own, a ghostly echo of a universe that lived and died before ours even began. Scientists are searching for this very evidence in the oldest light in the sky, the cosmic microwave background. This faint afterglow from the Big Bang is like a baby picture of our universe. Certain unusual patterns or anomalies in this radiation, like vast, unexplained cold spots or strange alignments, could be the scars left by a titanic collision with another universe, or more likely, the imprint of a previous cosmic cycle. Finding such a mark would be like discovering a fossil from a time before time, proving that our universe is just one chapter in an infinite, repeating story. This vision transforms our place in the cosmos from a singular event into a single line in an eternal poem, written over and over again, each time with a slightly different word that changes everything. The sheer number of possible realities is beyond any human ability to comprehend. String theory, our most ambitious attempt to unify all the forces of nature, paints a picture of a cosmos not with one set of rules, but with a near-infinite landscape of possibilities. This is the landscape multiverse. The theory suggests that the fundamental strings vibrate not in empty space, but within a substrate known as a vacuum state. This vacuum is not truly empty, it is filled with fields that give particles their mass and determine the strength of the forces. Crucially, this cosmic landscape is not smooth. It is a rugged terrain of countless valleys, hills, and peaks. Each stable valley in this landscape represents a different possible vacuum state, and each one corresponds to an entirely different universe with its own unique physical laws. The number of these possible valleys is not just large, it is astronomically vast. Physicists estimate there could be 10 to the power of 500 different configurations. That is a 1 followed by 500 zeros, a number so immense that every atom in our observable universe is vanishingly small by comparison. In one valley, the electromagnetic force might be so weak that atoms cannot form. In another, the cosmological constant driving the universe's expansion could be so strong that space-time is ripped apart moments after the Big Bang. Our universe simply occupies one of the very few valleys where the numbers are just right for galaxies, stars, and life to emerge. But how do new universes pop into existence within this landscape? The answer lies in a quantum quirk known as tunneling. Imagine a ball resting in one valley. Classically, it would need to be pushed up and over a hill to reach the next valley. But in the quantum world, there is a tiny but real probability that the ball can simply disappear from its valley and reappear in an adjacent one without ever climbing the hill. On a cosmic scale, this quantum tunneling event can create a tiny bubble of a new vacuum state. If conditions are right, this bubble can undergo a violent inflationary expansion, pinching off to become its own entire universe with its own distinct laws floating within the greater multiverse. This brings us to a profound and humbling idea, the anthropic principle. With 10 to the power of 500 universes in the landscape, it is statistically inevitable that a tiny fraction will, by pure random chance, have the perfect conditions for life. We should not be surprised to find ourselves in one of these rare, hospitable universes because we could not exist anywhere else. Our presence here is not proof of a grand design, but rather a selection effect. We are the cosmic lottery winners, living in a reality that allows us to look out at the stars and wonder about all the other, silent and barren worlds in the vast landscape of string theory. Every particle of matter in our universe has a perfect, shadowy twin. Antimatter is the mirror image of ordinary matter, identical in mass but with an opposite electrical charge. When a particle of matter meets its antimatter twin, they annihilate each other in a flash of pure energy. This perfect symmetry suggests a mind-bending possibility. What if entire stars and galaxies could be built from this antimatter, existing in a parallel cosmos where everything is reversed? This is the mirror universe concept, a theory born from a fundamental law of physics known as CPT symmetry. CPT stands for charge, parity, and time. The law states that if you take any physical process and flip the charge of every particle, mirror its spatial coordinates, and reverse the flow of time, the process should still obey the same laws of physics. In essence, the universe should look the same. This profound symmetry hints that a universe built from antimatter, where left and right are swapped and time flows backward, is not just possible, it might be inevitable. These mirror realities could be separated from our own by cosmic structures called domain walls. Think of these as vast, invisible sheets in space-time, barriers between regions of the cosmos with different fundamental properties. On one side of the wall lies our matter-dominated universe. On the other side, a universe made entirely of antimatter. If you could somehow pass through this domain wall, every atom in your body would instantly meet its antimatter counterpart, resulting in a catastrophic release of energy. This makes the wall a permanent, one-way boundary, isolating the two realities forever. Now imagine life in such a mirror universe. From our perspective, time there would appear to run backward. A star would not be born in a cloud of gas, but would instead draw light and energy from the void, growing younger and cooler until it dissolved into a pristine nebula. A living being in that world would experience its life in reverse, from death to birth, with memories of the future instead of the past. But here is the deepest mystery. Could consciousness exist in such a place? From the perspective of a being living in that universe, their arrow of time would feel perfectly normal and forward-moving, just as ours does. Their brains would process information from what we would call the future to the past, constructing a coherent experience of a life lived. They would remember tomorrow and anticipate yesterday, with their free will feeling just as real as ours. This forces us to ask what time and consciousness truly are. Is the flow of time an objective feature of the cosmos, or is it simply the direction in which our particular universe processes information and creates order? The mirror universe is not a place of science fiction, but a serious theoretical consequence of the very laws that govern our own reality, a perfect reflection waiting just on the other side of an invisible wall. Your own mind might be the architect of the reality you perceive. This is the conscious realities theory, a concept that places consciousness not as a passive observer, but as the active force that carves a single, stable world from the infinite possibilities of the quantum multiverse. We have already seen how the universe splits with every quantum event, but why do we only experience one outcome? Why do we find a cat that is definitively alive or dead and not both at once? The answer, according to this theory, is that your conscious observation is what solidifies one branch of reality over all the others. It is not that you are causing the universe to split. The splitting is always happening. Instead, your awareness acts like a spotlight, illuminating one path on the infinite tree of possibilities and making it real for you. The other branches continue to exist, but for you, they remain in darkness, unexperienced and unreal. This idea bridges the cold equations of quantum mechanics with the deepest questions of philosophy. It suggests that the world you see around you, from the chair you are sitting on to the screen in front of you, is the one specific reality that your consciousness has selected to engage with. A different conscious being with a different type of mind might engage with a completely different branch from the same quantum foundation. Cognitive scientist Donald Hoffman takes this even further with his interface theory of perception. He proposes that our senses are not showing us the true nature of reality at all. They are like a computer desktop interface designed for utility and survival, not for truth. You do not need to understand the complex circuitry and code of your computer to click on an icon and open a file. In the same way, we do not need to perceive the true, mind-bending complexity of the quantum world to navigate our lives successfully. Space, time, and physical objects are simply the icons on our conscious desktop, a user-friendly illusion that hides a reality far stranger than we can imagine. This means that a dog, a bat, or an octopus, with their different sensory apparatus and brain structures, might be interacting with a reality that looks and feels entirely different from our own, all built from the same underlying quantum substrate. The philosophical implications are staggering. If consciousness determines reality, then the entire cosmos becomes a deeply personal experience. The solid ground beneath your feet, the warmth of the sun, the love you feel for another person, all of these are the specific manifestations that your mind has chosen to make real. This leads to a profound question about free will. Are you truly making choices, or is your consciousness simply following a pre-written script on the quantum tree, believing it is in control? Or perhaps your choices are the very mechanism that navigates the branches, making you the co-author of your own cosmic story. We are left to wonder if the ultimate mystery is not out in the stars, but within our own minds, the final frontier where reality is born. Philosopher David Lewis proposed a theory so absolute it makes the multiverse feel claustrophobic. His idea, called modal realism, argues that every possible world is not just a physical reality, but a concrete, actual place just as real as our own. This is not a theory about quantum mechanics or cosmic inflation. It is built purely on logic and philosophy. If you can coherently describe a world, no matter how strange, it exists out there in the vast plenitude of being. Think of every story ever told, every history book describing what might have been, every daydream you have ever had. According to Lewis, there is a world where the Roman Empire never fell, a world where you became a professional athlete, and a world where dinosaurs evolved sentience and built cities. These are not fantasies. They are locations in a reality so expansive that the word universe is no longer sufficient. The most shocking part of this philosophy is its scope. It includes worlds that operate under laws of logic completely alien to our own. We take for granted that something cannot be both true and false at the same time, a principle known as the law of non-contradiction. But what if there is a world where this law does not hold? In that reality, a single object could genuinely be a fully grown tree and a tiny sapling simultaneously. A person could be both alive and dead in a way that is not a quantum superposition, but a brute fact of their existence. These are not just different physics, they are different frameworks for what is even conceivable. Your identity becomes a sprawling, fractured concept across this plenitude. There is not just one version of you reading this script. There is a you who decided to close the video a minute ago, a you who was never born, and a you who is a literal king of a distant planet. These are all equally real individuals, not mere possibilities. They are your counterparts living out the full spectrum of every decision you could have possibly made. This forces us to confront the nature of morality. If every bad action you refrain from is committed by a counterpart in another world, are you still a good person? Lewis would argue yes, because your moral worth is tied to the choices you make in this specific world, the one your consciousness currently inhabits. Your goodness is not diminished by the actions of a distant double. Knowledge itself gets turned on its head. How can we claim to know anything for certain if there are worlds where our most cherished facts are false? We know that gravity makes things fall down, but in a world with different physics, gravity might make things fall up. Modal realism suggests that our knowledge is not about universal truths, but is indexical. It is true only for this particular world we find ourselves in. We are not discovering the one true set of laws, we are simply reporting the local bylaws of our cosmic neighborhood. This philosophical stance presents a reality of absolute plenitude, where nothing is merely possible and everything that can be simply is. Quantum decoherence provides the physical mechanism that permanently severs one reality from another. It explains why you never actually see a cat that is both alive and dead, but instead find it definitively in one state. A quantum system, like that cat in the box, begins in a superposition, a ghostly blend of all possible states. This fragile coexistence cannot last once the system interacts with its environment. The moment a single photon of light bounces off the cat, or a molecule of air touches the box, information about the system state leaks out into the world. This interaction is like dropping a stone into a still pond. The initial splash creates a complex interference pattern, a messy overlap of ripples representing all possible outcomes. But as those ripples spread outward, they quickly separate into distinct, individual wave patterns that no longer interact. They become independent realities on the surface of the water. In exactly the same way, the act of observation forces the quantum system to entangle with its environment. The superposition collapses not into one state, but rather, the entire system and its environment split into separate, non-interacting branches. One branch contains you, the box, and a living cat, all consistent with each other. The other branch contains a different version of you, the same box and a dead cat. Decoherence is the process that makes this split permanent. It severs the quantum links between the branches so completely that they effectively become their own independent classical universes, forever sailing apart in the vast Hilbert space of all possibilities. This happens with breathtaking speed for any object larger than an atom, which is why the weirdness of quantum superposition is hidden from our everyday view. The universe seems solid and definite because decoherence has already done its work, trillions of times over for every particle around you. A profound question then arises. If these branches are forever separate, can they ever reconnect? Could two parallel realities ever cross paths again? The grim answer from decoherence is almost certainly not. The process is irreversible. Once the information has scattered into the environment, it is like trying to gather smoke back into a gun. The countless tiny interactions that define the branch make it astronomically unlikely for the paths to ever interfere with each other again. They are like two ships that set sail from the same harbor on slightly different courses. At first, they are close, but as they journey across the ocean, the gap between them widens into an impassable expanse. Each universe becomes its own isolated story, forever unaware of the infinite other stories being written just a breath away. Deep within the crushing darkness of a black hole, an entire cosmos might be waiting to be born. This is the black hole universe hypothesis, a theory proposing that every single black hole is not an end but a beginning. When a massive star collapses, it does not simply vanish into a point of infinite density. Instead, the theory suggests the mind-bending physics at the singularity could trigger a new Big Bang, birthing a fresh universe entirely separate from our own. Inside that new reality, space and time would be reborn with its own galaxies, stars, and potentially its own life forms completely unaware of the parent cosmos that spawned it. This creates a fractal multiverse, a cosmic matryoshka doll where universes exist within universes, each one nested inside the black holes of a reality one level up. The journey into this cosmic nesting doll begins with the event horizon, the point of no return. Once matter crosses this boundary, it is destined for the central singularity. Our current laws of physics break down at this point, but some models suggest the collapse does not stop. It could rebound, a concept sometimes called a quantum bounce. The immense pressure and density could act like a cosmic seed, triggering a new period of inflationary expansion, effectively creating a new space-time continuum that is causally disconnected from our own. This leads to a profound question about our own home. Could our vast, expanding universe with its billions of galaxies simply be the interior of a black hole residing in a much larger parent universe? The mathematics can support this startling idea. For instance, the amount of information contained within our observable universe correlates with the surface area of its boundary, much like the information of a three-dimensional object is encoded on a two-dimensional surface, a principle we saw with the holographic universe. If our cosmos is a black hole interior, then the cosmic microwave background, the oldest light we can see, might be the encoded information on our own event horizon. If our universe is inside a black hole, what would the other side look like from the perspective of the parent universe? The theoretical answer is a white hole. If a black hole is a region of space-time from which nothing can escape, a white hole would be its opposite, a region from which nothing can enter, only erupt. It would be a fountain of matter and energy, spewing out a new universe in a single explosive event. From the outside, the creation of our universe 13.8 billion years ago would have looked like the sudden appearance of a white hole, violently releasing all the energy that would eventually form every galaxy we see today. This transforms our entire cosmic history into a single, ongoing event within a grander cosmos. Every black hole we observe, from the stellar mass ones to the supermassive giants at the centers of galaxies, could be pregnant with their own entire realities. And within those new universes, the process would repeat. Their stars would live and die, forming new black holes, each one birthing another generation of cosmos in an endless fractal chain of creation. We are left to wonder if we are living in the original universe or just one branch on an infinite tree of realities, each one blooming in the absolute darkness of a singularity. The very moment you hear these words is not slipping away into the past. It is a permanent fixture in the cosmos, a frozen slice of reality as solid and real as the ground beneath your feet. This is the time slice multiverse, an eternalist vision where the past, present, and future all exist simultaneously. In this block universe model, time is not a flowing river but a fourth dimension, much like length, width, and height. Our entire history, from the Big Bang to the last star blinking out, is a single, immense four-dimensional block where every moment is eternally present. Your birth is happening, your first day of school is happening. Every moment of joy and sorrow in your life is not a memory or a hope, but a concrete event occurring right now in its own specific coordinate within the block. This means there are not just parallel universes for different choices, but an infinite stack of parallel realities for every single instant that has ever occurred or ever will. The feeling that you are moving through time from one moment to the next is an illusion of your consciousness. Your awareness is like a spotlight scanning across a vast film reel. The spotlight illuminates one frame at a time, creating the subjective experience of a present moment, but the entire reel with all its frames exists at once. Your consciousness of 5 seconds ago is still out there, preserved in its own time slice, and the you of 5 seconds from now is already just as real, waiting for the spotlight to arrive. This has a staggering implication for free will. If the future is already written into the block, are you truly making choices, or are you just reading a script that has existed for all eternity? Your feeling of deliberation, of weighing options, might be an unavoidable part of the process, a necessary step written into your personal timeline. You are the character in a book who believes they are writing the story as they go, unaware that the entire narrative from the first page to the last is already complete. Yet, this does not necessarily make your life predetermined in a fatalistic sense. The block contains every possible branching path created by quantum events. So the future is not a single fixed line, but a vast blooming tree of possibilities, with every branch and twig existing eternally within the grand structure. Your journey through the block is the exploration of one of these intricate, pre-existing paths. The profound beauty of this theory is that it grants a kind of immortality to every moment. A cherished memory is not a fading ghost. It is a permanent part of the cosmic structure, forever playing out in its own slice of space-time. Every lost loved one in their own time slice is still laughing, still living, still existing in the eternal now. We are all permanent residents of the infinite museum of time, each occupying our own display case, forever frozen and forever real. The universe might not be made of atoms, but of pure information. This is the ultimate extension of the mathematical universe. A theory championed by physicist John Archibald Wheeler called it from bit. He proposed that every particle, every force field, and even space-time itself ultimately derives its existence from binary answers to yes or no questions. The cosmos is not a physical machine. It is a cosmic computer processing an unimaginable flow of information. The ultimate ensemble theory takes this idea to its logical extreme, suggesting that every possible computational structure exists as a concrete reality. This goes far beyond universes with different physics. It includes every conceivable abstract mathematical space, every possible simulation, and every self-consistent set of logical rules. If a structure can be described or computed, it is real somewhere in the multiverse. Our universe is simply one specific computational structure that has the right properties to support complex patterns like stars, planets, and us. Think of a simple cellular automaton like Conway's game of life, a grid of cells that turn on or off based on a handful of simple rules. From those basic computational laws, incredibly complex and seemingly unpredictable patterns can emerge, gliders and stable structures that behave almost like living organisms. Now imagine a computational system infinitely more complex, with rules that allow for the emergence of self-awareness. In that digital cosmos, conscious beings could arise, living their entire lives within the computation, completely unaware that their reality is built on logic gates instead of atoms. Their physical laws would be the rules of the program. Gravity might not be a fundamental force, but an emergent property of how data is processed in their virtual space. What would consciousness be like in such a reality? A being in a purely mathematical universe, one built on the geometry of a four-dimensional sphere, might experience thought as a navigation through hyperspatial relationships. Their emotions could be tied to solving intricate topological puzzles, a consciousness emerging from a computational system designed for pure logic, with no analog for sight or sound, might perceive reality as a vast, flowing symphony of pure reason and elegant proofs. Their entire existence could be a continuous, ecstatic experience of understanding deep mathematical truths. This theory forces us to reconsider the nature of our own minds. If we are part of a computational structure, are our thoughts and feelings just extremely sophisticated algorithms? Is the rich tapestry of human experience, from the taste of chocolate to the feeling of love, merely the output of a complex program running on the hardware of space-time? Or is consciousness the fundamental ingredient, the one thing that gives meaning to the computation itself? We are left to wonder if we are living in a universe of things or a universe of thoughts where the only true reality is the endless, shimmering sea of information. The resolution of our cosmic projection might not be fixed. Just as a digital image can range from a blurry, pixelated mess to a hyper-realistic masterpiece, the holographic encoding on our universe's boundary surface could have been set to any number of possible values. This single parameter, the fundamental pixel size of reality, could dictate the very laws of physics within the projected space. In our universe, this resolution is astonishingly fine, a scale known as the Planck length, which is so small that a single atom is comparably vast. This incredibly high definition is what allows for the rich complexity of galaxies, chemistry, and life itself. But imagine a universe where the holographic encoding is much coarser. In that reality, the pixel size might be as large as a planet. There, the concept of a tiny, stable atom would be impossible. Matter could not form intricate structures, and the entire cosmos would be a featureless, low-resolution fog, incapable of supporting any form of organized complexity. The sharp, defined laws of physics we take for granted would dissolve into a blur of statistical noise. The encoding scheme itself is another variable. Our universe seems to run on a specific set of mathematical rules, a kind of cosmic programming language that generates forces like gravity and electromagnetism. But what if the code were written differently on the boundary? A holographic universe could be programmed with a law that allows for 5 spatial dimensions instead of our 3. Beings in that reality would perceive and move through directions we cannot even visualize. Another encoding might remove the speed of light as a universal speed limit, creating a cosmos where information travels instantaneously and causality itself breaks down. Each unique hologram, defined by its resolution and its code, projects a universe with systematically different properties. This creates a vast family of related realities, a holographic multiverse where the rules are not random but are direct consequences of the settings on the projector. The search for evidence of this is already underway. Scientists meticulously analyze the cosmic microwave background, the oldest light in the universe, which is essentially the first image ever projected. They are looking for subtle anomalies, specific patterns of noise or correlations in the temperature fluctuations that could reveal the underlying pixelation of spacetime. Finding a signature of this granularity would be like discovering the scan lines on our cosmic television screen, the first hard proof that we are living inside a projection. It would also hint at the existence of other projections, other holograms running on different settings, each one a self-contained reality with its own unique and unwavering laws, all emanating from the infinite potential of a two-dimensional code. At the absolute smallest scales of existence, the fabric of space-time is not smooth and serene. It is a seething, turbulent ocean. This is the realm of quantum gravity, where the rules of the very small and the rules of the very large collide in a chaotic dance. Here, in what physicists call space-time foam, the concepts of here and now lose all meaning. Space and time themselves become fuzzy and discontinuous, bubbling with potential. Within this frenzied quantum foam, tiny virtual particles constantly pop in and out of existence, borrowing energy from the vacuum for fleeting moments. But sometimes a quantum fluctuation is not just a particle. Sometimes it is an entire universe. A microscopic bubble of a new vacuum state can spontaneously form, a seed of spacetime with its own distinct properties. Most of these nascent universes are stillborn, collapsing back into the quantum static almost instantly. Yet, a rare few possess the precise conditions to trigger a runaway process known as inflation. A powerful repulsive force takes hold within the bubble, causing it to expand at an exponential rate far faster than the speed of light. In a heartbeat, this quantum speck is stretched into a macroscopic cosmos, pinching off from its parent foam to become a full-fledged, self-contained universe, adrift in a greater multiverse. This process, known as eternal inflation, provides the engine for the bubble multiverse we explored earlier. Our entire cosmos could be just one such successful bubble in an endless, frothing sea of creation, where new universes are constantly budding off from the chaotic substrate of reality. The challenge of uniting quantum mechanics with Einstein's general relativity has been the single greatest problem in theoretical physics for a century. Quantum gravity is the sought-after theory that would describe how gravity works at this microscopic, frothy level. We lack a complete picture, but frameworks like string theory and loop quantum gravity offer glimpses. They suggest that the continuous geometry of spacetime we experience is an emergent illusion, and that at the Planck scale, reality is granular, woven from discrete, vibrating loops or strings. It is from this fundamental graininess that the quantum foam arises, and with it, the potential for endless cosmic birth. This provides a stunningly elegant mechanism for the origin of everything. No single, definitive Big Bang is required. Instead, the multiverse is eternally self-replicating, a cosmic ecosystem where universes beget more universes. Each new bubble inherits a random set of physical constants from the quantum fluctuation that birthed it, leading to the incredible diversity of realities in the cosmic landscape. We find ourselves in one of the rare, stable bubbles where the numbers allowed for galaxies and life to form. Our existence is not the result of a 1 in a trillion accident, but the inevitable outcome of an infinite number of rolls of the cosmic dice, happening forever in the bubbling depths of quantum gravity. Our universe appears suspiciously well designed for our existence. If the force of gravity were just a fraction stronger, the cosmos would have collapsed back on itself moments after the Big Bang. If it were slightly weaker, galaxies and stars could never have coalesced from the primordial gas. This delicate balance is not limited to gravity. The nuclear forces that power the stars and forge the elements in their cores are also tuned to a razor's edge. This apparent fine-tuning has led to one of the most profound and debated ideas in cosmology, the anthropic principle. In its simplest form, the weak anthropic principle states that the universe must be compatible with the conscious life that observes it. We should not be shocked to find ourselves living in a universe with breathable air, liquid water, and stable stars, because we could not exist in a universe that lacked these things. It is a statement of a simple, almost obvious selection effect. The strong anthropic principle takes a much more controversial stance. It suggests that the universe must have properties that inevitably lead to the emergence of life. This version hints at a form of teleology, a built-in purpose or design that makes the universe inherently life-friendly. The multiverse offers a powerful and, for some, a chilling resolution to this puzzle. In a landscape of 10 to the power of 500 universes, every possible combination of physical constants will be realized somewhere. The vast, overwhelming majority of these universes will be stillborn or barren. They will have laws that prevent atoms from forming or forces that rip space apart. But by the sheer, staggering weight of infinity, a tiny fraction of universes will, through pure random chance, have the exact right numbers for life to emerge. We are not special, and our universe is not purpose-built. We are simply the inevitable inhabitants of one of the rare, habitable islands in a vast, mostly dead multiversal sea. Consider the cosmological constant, the energy density of empty space. If this value were just a little larger than what we observe, the universe would have expanded so rapidly that no galaxies could form. If it were slightly smaller, gravity would have caused the entire cosmos to recollapse long before life had a chance to arise. The value we see is fine-tuned to 1 part in 10 to the power of 120, a number so incomprehensibly small it defies any notion of mere chance in a single universe. Yet, in an infinite multiverse, this improbable value is not just possible, it is guaranteed to occur in at least some realities. Critics argue that the anthropic principle is a cop-out, a way to avoid searching for a deeper, more fundamental theory that explains why our constants have the values they do. They contend that invoking an infinity of unseen universes is not true science, as it makes no testable predictions. Why should we resort to a cosmic lottery when a single, elegant theory might one day explain it all? Proponents counter that the multiverse is the most straightforward explanation for the data we have. The fine-tuning is real, and the anthropic principle within a multiverse is the most natural solution. This debate forces us to confront our place in the cosmos. Are we the beneficiaries of a cosmic accident, living in a universe that won the ultimate jackpot? Or is there a deeper reason for our existence, one that we have not yet uncovered? The answer, for now, remains written in the constants of nature, a silent code waiting to be deciphered. Your own mind could be the only thing anchoring you to this specific reality. The many minds interpretation offers a dizzying twist on the quantum multiverse, one that unfolds not in the stars but within your own consciousness. This theory suggests that when a quantum event like Schrödinger's cat experiment occurs, the universe itself does not split. Instead, it remains in a single, sprawling superposition, a ghostly blend of all possible outcomes. What splits is not the cosmos, but your awareness of it. Your single stream of consciousness fragments into multiple, separate minds, each one perceiving a single, definite result from the quantum haze. One mind sees a living cat, while another, just as real, experiences a dead cat. Both minds exist within the same physical universe, but they are forever isolated from each other, each one inhabiting its own private, perceptual reality. This directly tackles the infamous measurement problem in quantum mechanics, the puzzle of why we only ever see one definite outcome from a blur of possibilities. The many minds answer is that the blur never goes away. The superposition persists, and our individual minds simply become locked onto one thread of that complex tapestry, blind to all the others. This means that you and your best friend could, in theory, be experiencing different versions of the same room right now. Perhaps in your reality, the book on the table is blue, while in their perceptual branch it is red. The physical object itself is in a superposition of both colors, but your minds have decoded, latching onto different aspects of the same quantum reality. You would never know because your experiences are perfectly consistent from your point of view, and any attempt to compare notes would itself become a quantum event, forcing your realities to align or branching your minds yet again. The philosophical implications are profound. It suggests that true, objective reality may be forever beyond our grasp, a swirling quantum soup that we can only sample in thin, disconnected slices. We each live in a personalized universe curated by our own observation. The world you perceive is not the world as it is, but the world as your mind has selected it to be. This raises a haunting question about our shared experiences. If we all inhabit private realities, how do we manage to agree on anything at all? The theory posits that our minds tend to branch together when we interact, creating the powerful illusion of a common world. We are like a school of fish swimming in a quantum ocean, our perceptions synchronized by constant contact, creating a stable, shared hallucination we call reality. But deep down, your red might not be my red, your yesterday might not be my yesterday. You are the sole, permanent resident of your own cosmic story, and every other person you meet is just a fleeting visitor, their consciousness briefly intersecting with yours before branching away on its own unique and solitary journey through the infinite possibilities of a single shared universe. Our universe might have been born not from a single point of fire, but from a silent cosmic collision in the dark. This is the ekpyrotic universe scenario, a theory where our entire cosmic history began when two immense parallel worlds slammed into each other. Picture our three-dimensional universe as a vast, flexible membrane or brane drifting in a higher dimensional space. Another, similar brane floats parallel to our own, separated by a gap thinner than an atom. Over eons, these two colossal sheets drift closer, drawn together by an unseen force. They do not collide with a violent explosion, but with a smooth, scraping contact, a gentle kiss that transfers an immense amount of energy into our brain. This infusion of energy becomes the hot, dense state we call the Big Bang, setting off the expansion and evolution of everything we see. This model offers a radically different vision from the traditional story of a singularity, a point of infinite density appearing from nothing. Here, the Big Bang was not the absolute beginning, but a phase transition, a rebirth from a previous state of existence. The cosmos operates in an endless, cyclic rhythm of approach, collision, and separation. After the branes collide and create a new universe, they drift apart, only to be drawn together once more billions of years later, triggering the next cycle. Each collision is not a perfect replica of the last. Quantum fluctuations during the moment of impact introduce tiny, random variations in the new universe's fundamental properties. In one cycle, the strength of the electromagnetic force might be a fraction stronger, leading to a universe where stars burn with a different color and life, if it emerges, is built on different chemistry. In the next cycle, the mass of the fundamental particles could be lighter, creating a cosmos that expands far more rapidly. This process creates a sequence of parallel realities, not existing side by side, but one after another in a grand cosmic cycle, each one a slightly altered version of the one before it. How could we ever find evidence for such an extraordinary event? The telltale sign would be imprinted on the oldest light in the sky, the cosmic microwave background. The gentle, scraping collision of two branes would not create the violent, chaotic gravitational waves predicted by some inflation models. Instead, it would produce a very specific, faint pattern of polarization in this ancient light, a subtle swirl that telescopes are actively searching for today. Furthermore, this model naturally explains why our universe appears so incredibly flat and uniform on large scales. The long, slow approach of the branes before the collision acts like a cosmic iron, smoothing out any wrinkles or curvature, leaving behind the pristine, homogeneous universe we observe. Finding that distinctive signature would be our first direct glimpse into the higher dimensional arena where our reality is just one of many players in an eternal, rhythmic dance of creation and destruction. This idea of quantum immortality transforms the end of life into a deeply personal paradox. If your consciousness only follows the path where you survive, then from your own subjective point of view, you might never experience death. A terminal illness would present a bizarre sequence of events. You receive the diagnosis, but then a series of improbable quantum events always intervenes. A new experimental treatment is discovered at the last possible moment. A spontaneous remission occurs against all medical odds. In every conceivable timeline where the illness takes you, your awareness is not there to witness it. You are forever the version of you that finds the miraculous cure, no matter how statistically unlikely it seems. This logic extends to the aging process itself. Do you simply live on, experiencing an endless series of quantum reprieves, until you are the last conscious being in a universe grown cold and dark? Or does your consciousness eventually jump to a timeline where the science of radical life extension has succeeded, allowing you to continue indefinitely? The theory suggests you would perceive yourself as impossibly lucky, always cheating death through a cascade of fortunate accidents. The psychological weight of such an existence is difficult to fathom. Believing you are immortal in this quantum sense could lead to profound detachment or a terrifying sense of loneliness. Every personal loss you experience would be a reminder that you are on a solitary path, forever separated from the counterparts you love. Ethically, it could be used to justify reckless behavior, a dangerous gamble on the universe always providing an escape route. Yet this is a profound misunderstanding of the theory. While your consciousness might always find a branch where you survive, the you in this reality is not invincible. Your actions have consequences here and now, in this specific world you currently inhabit. This framework offers a controversial lens through which to view near-death experiences. Those who report seeing a tunnel of light or a life review could be interpreted as momentarily perceiving the branching tree of possibilities, their consciousness brushing against the infinite versions of their own story before latching back onto a viable thread. It connects deeply to studies of consciousness, posing the question of whether the mind is a passive passenger or an active navigator on this quantum tree. Are we simply along for the ride on a predetermined branch of survival, or does our focused awareness somehow steer us toward continuance? The theory provides no comfort, only a cold, mathematical form of eternity, where you are both the beneficiary of infinite chance and a prisoner of your own unending story. A message from another reality could arrive not as a radio signal, but as a ghostly whisper in the data of a quantum computer. The possibility of communicating across the infinite divide of the multiverse rests on one critical question. Could any physical connection, any thread of cause and effect, possibly stretch between two separate cosmic bubbles? Some theoretical models suggest that under specific, extraordinary conditions, the answer might be yes. One proposed mechanism involves quantum entanglement, that strange phenomenon where two particles remain mysteriously linked regardless of distance. What if a pair of particles became entangled before their respective universes pinched off from a common quantum origin? These twin particles, now stranded in different realities, could still share a spooky connection. A scientist in our universe manipulating her particle would instantly affect its twin in the parallel world. The challenge is interpreting this effect. A change in a single particle's spin is not a message, it is cosmic noise. To build a language from such a faint signal would be like trying to read a novel from the random flickering of a single photon. A more dramatic possibility involves the collision of entire realities. In the brane multiverse, where our universe is a three-dimensional membrane floating in a higher dimensional bulk, two such branes could occasionally collide. Such an event would not be subtle. The transfer of immense energy would leave a permanent scar on the fabric of our cosmos. Astronomers are actively searching for this evidence in the cosmic microwave background, looking for strange, circular patterns or inexplicable temperature variations that could be the cosmic bruise from a long-ago impact with a neighboring universe. That collision itself would be a form of communication, a single, catastrophic message written in the very first light of creation. If a civilization in a parallel universe wanted to send a deliberate message, how would they do it? They might not use electromagnetic waves at all. They could manipulate the fundamental constants of their reality, creating a ripple in the very laws of physics that might propagate through the bulk and subtly alter the forces in our own world. We might one day discover that the strength of gravity is slowly, inexplicably changing, and realize we are witnessing an attempt at contact from a cosmos with a different set of rules. The content of such a message is beyond our guessing. It could be a simple mathematical sequence, a universal hello, or it could be a warning, a desperate signal from a universe that has already encountered a threat we cannot yet conceive. The paradoxes of cross-universe communication are as vast as the idea itself. If you received a message from a parallel version of yourself telling you not to make a specific choice, would you be compelled to obey it, or would your act of receiving the message itself create a new branch where you do the opposite? Any transfer of information between timelines could create insurmountable logical loops where cause and effect become completely untangled. Science fiction has long played with these concepts, from stories of ham radio operators contacting alternate Earths to visions of portals opening between dimensions. While these are fictional tales, they highlight a deep human yearning to know we are not alone, not just in our universe, but in the entirety of existence. The ultimate truth may be that the voids between universes are truly impassable, designed to protect the sanctity of each individual timeline. Or perhaps the first message is already on its way, a ripple in the quantum field we have not yet learned to read. Scientists are actively hunting for the fingerprints of other realities in the data we can observe. The cosmic microwave background, that ancient afterglow from the Big Bang, is our most promising cosmic photo album, and researchers are meticulously scanning it for any sign of a bruise. They are searching for specific, unusual patterns, like a vast, circular cold spot or a distinct statistical anomaly in the temperature fluctuations that could be the imprint of a long-ago collision with a neighboring bubble universe. Finding such a scar would be the first direct evidence that our cosmos is not alone, but one bubble in a vast, foaming multiverse. The search extends deep underground to powerful particle accelerators like the Large Hadron Collider. When physicists smash particles together at nearly the speed of light, they are recreating the universe's earliest moments. In these incredible collisions, they hope to see something vanish. If energy or a particle seems to disappear from a collision event, it could be a sign that it has momentarily slipped into an extra dimension predicted by brane multiverse theories. They are also watching for the production of exotic particles like microscopic black holes or gravitons, which could reveal how gravity leaks between branes, explaining its surprising weakness in our world. Astronomers are also turning their telescopes to the heavens, looking for strange gravitational effects that cannot be explained by the visible matter in our universe. While dark matter is the primary suspect for these anomalies, some scientists speculate that certain unexplained gravitational tugs could be the influence of a parallel reality hovering incredibly close to our own in a higher dimension, its gravity faintly seeping into our cosmos. This is not just theoretical. Experiments have already placed limits on the size and nature of these extra dimensions, and the search for cosmic bubble collisions continues with increasing precision. Future missions, like advanced space telescopes designed to map the cosmic microwave background in unprecedented detail, are being planned specifically to hunt for these multiversal signatures. We are no longer just imagining other worlds, we are building the tools to find them. The greatest discovery in human history might not be a new planet or star, but the first undeniable proof that our entire reality is just one room in an infinite cosmic mansion. These infinite possibilities force us to confront the very foundation of our own morality. If every choice we do not make is being lived out by another version of us, does that render our own decisions meaningless? Some philosophers argue it does, suggesting that an infinity of views dilutes the significance of any single life into cosmic static. Your achievements are not unique, your failures are not final, and the weight of your choices evaporates in a sea of alternatives. This is the threat of existential nihilism, where the multiverse seems to strip our lives of any special purpose. Yet another school of thought proposes the exact opposite. The fact that your consciousness is experiencing this specific timeline with all its unique joys and sorrows makes it profoundly significant. You are not living every life, you are living this one. The choices you make here define the character of this particular story, the only story you will ever know. Your kindness in this reality is not diminished by a counterpart's cruelty in another. It is the definitive moral act of your world. Your responsibility is not to the infinite crowd of your other selves, but to the people in this universe right here and now. This perspective transforms regret from a burden into a marker of your unique path. The road not taken is not a lost opportunity, but simply a road you are not traveling. Your life is a sculpture carved from the infinite block of possibility, and every choice is a deliberate cut that gives it its distinct and irreplaceable shape. The concept of personal identity shatters and reforms under this pressure. Are you the sum of all your potential selves, or is the you reading this the only real you? Thinkers like Derek Parfit argued that what matters is not a continuous, unchanging self, but the psychological connectedness between your present and future states. In the multiverse, this connectedness is what defines your specific thread through the cosmic tapestry. You are the narrative that this particular consciousness is weaving. This raises a haunting ethical question about suffering. If every tragedy is balanced by a version of events where it was avoided, does that make the pain in our world any less real or deserving of our compassion? The overwhelming philosophical answer is no. The existence of a happy universe does not justify the agony in a sad one. Our moral duty remains fiercely local to alleviate the suffering we can touch in this, our shared reality. The multiverse does not absolve us of our humanity. It demands that we cherish it all the more fiercely, for in an ocean of infinite stories, the one we are writing together is the only one we have the power to change. These separate threads of reality might all be woven into a single, breathtaking tapestry. The bubble universes, the branching quantum worlds, and the holographic projections are not necessarily competing ideas. They could be different perspectives on a far grander, unified multiverse. Think of it as a cosmic ecosystem with multiple levels. At the very foundation, in the seething quantum foam, new bubble universes are constantly being born through eternal inflation. Each of these bubbles has its own unique vacuum state, its own set of physical laws drawn from the vast landscape of string theory. Within each of these stable bubbles, the local rules take over. In a bubble like ours, quantum mechanics operates, and the many worlds interpretation takes hold, endlessly splitting the timeline within this one cosmic domain. And within that, our specific reality might be a holographic projection encoded on its distant boundary. One framework does not cancel out another. Instead, they nest inside each other like a set of Russian dolls. A branching quantum reality is not a rival to a bubble universe. It is what happens inside of one. Scientists are now asking if these theories are special cases of a deeper, more fundamental description of reality. The holographic principle, for instance, might be a property of all space-time, not just black holes or our cosmic horizon. It could be the operating system on which all the other multiverse levels run. The brane collisions of the ekpyrotic model could be the specific mechanism that triggers the birth of new bubbles in the wider inflationary multiverse. The challenge and the goal of modern theoretical physics is to find a single theory that naturally gives rise to this entire hierarchy. The dream is a framework where the quantum nature of gravity, the physics of the Big Bang, and the existence of other universes all emerge from a single, elegant set of equations. Researchers are exploring visual models to represent this complexity. One powerful image is the multiverse tree. The trunk represents the fundamental, perhaps string-theoretic reality. Major branches splitting from the trunk are the distinct bubble universes, each with different constants. From those branches, smaller twigs represent the quantum many worlds branching within each bubble. And the leaves on those twigs could be the individual holographic projections or time slices that make up our perceived reality. Another model is the cosmic ocean, where each bubble universe is a separate island. On some islands, the local physics allows for their own inland seas of quantum branching, creating an ever-ramifying coastline of possibilities. The ultimate goal is to find a mathematical language that can describe this entire structure. This means merging the probabilistic rules of quantum mechanics with the geometric fabric of general relativity and the extra-dimensional possibilities of string theory into one coherent whole, often called a theory of everything. Current research is pushing on all these fronts. Cosmologists analyze sky maps for the scars of bubble collisions. quantum physicists run experiments on entanglement to probe the foundations of reality. String theorists calculate the properties of the cosmic landscape. They are all gathering pieces of the same grand puzzle. The most profound realization is that our universe is not just one thing. It is a multi-layered, deeply nested phenomenon, and our search for its true nature is forcing us to invent a new science, one capable of mapping the infinite. Our journey through the multiverse reveals a cosmos far grander and more mysterious than we ever dreamed. We have seen how every choice might spin off a new reality, how our universe could be a single bubble in an endless cosmic foam, and how the solid world around us might be a holographic projection from the edge of space. These are not just science fiction fantasies, they are serious scientific theories grounded in the rigorous mathematics of quantum mechanics, string theory, and cosmology. Each one fundamentally challenges our most basic assumptions. There is no single reality, no objective flow of time, and perhaps no distinction between the physical and the mathematical. Our very consciousness might be the spotlight that carves a stable world from an infinite sea of quantum possibility. The takeaway is humbling and exhilarating. We are not at the center of a single, special creation. We are participants in an infinite tapestry of existence, where every story that can be told is being lived out somewhere. This expansion of reality redefines our place in the cosmos. It invites us to let go of a singular, fixed universe and embrace a reality of endless becoming. The exploration does not end here. The greatest discoveries about the nature of existence still lie ahead, waiting at the frontiers of science. We want to hear which of these theories reshaped your understanding of reality the most. Share your thoughts in the comments below, and if you are eager for more journeys to the edge of knowledge, subscribe now. The next time you look up at the night sky, remember that you might not be looking out but across into one of countless other worlds, each with its own story, its own laws, and its own version of you, all existing in the incredible vastness just beyond our perception.